Today's lesson is polynomial applications. These are box and fence type problems. So our learning objective for today is I can extend my learning of polynomials to real world problems by using familiar formulas together for solving for extrema. And what does this look like? Instead of asking for solving for a minimum or a maximum, the kind of questions that are asked are, what's the largest a volume package at the post office will take, or what is the quickest way to get from here to there, or what is the least expensive way to do some tasks. So these are minimum and maximum problems, but they don't say the words minimum or maximum. Okay, so we're going to just look at a couple common formulas from geometry that we're going to use. Well, perimeter is 2 times the length plus 2 times the width. Area is length times width. Volume is length times width times volume, or length times width times height. All right, so let's start out with a fence problem. So a fence problem says a rectangular enclosure divided into 2 sections is to be constructed using 60 meters of fencing. Draw a diagram. Okay, so I'm making a rectangle into 2 sections. And to have it look like a fence, let's make it look like a chain link fence. Okay. So my 60 meters of fence is all of the 2 outside enclosures. So the first question, or B, says write a function that expresses the area of the enclosure as a function of its width. So it's asking me what is the area in terms of width. So I know area is length times width. So right now I know this is my length and this is my width. And so since it's not a standard perimeter problem because I have more than one object, I'm going to kind of modify it to say exactly what this 60 meters of fencing is. So I know there are 2 lengths and 3 widths of fencing. So I know that I can solve for length in terms of width. Because I'm trying to set up for my equation, I want area equals length times width, but I want to rewrite length in terms of width. And I do that by using another equation. So I'm using my perimeter information. So I'm going to set up as 2 times length plus 3 times width equals my fencing, which is 60. So I'm going to subtract 3w from both sides. So 2 times length equals 60 minus 3w. Divide both sides by 2, so I get length equals 30 minus 1.5w. So now I'm just substituting in my area formula. So area in terms of width is length, which is 30 minus 1.5w times width. So I have my area in terms of one variable, and that's what my goal was. All right, next, I want to find the domain algebraically. So looking at my equation is not a fraction, and it is not a radical with an even index. So mathematically, I don't have any restrictions. But in the real world, my restrictions are everything, length, width, perimeter, and area have to be greater than 0. So length, width, perimeter, and area would all need to be greater than 0. So that's a real world restriction. So my length has to be greater than 0. So my length is 30 minus 1.5w has to be greater than 0. And my width has to be greater than 0. And my width is just W, so I'm done with width. So solving for W over here, I'm going to subtract 30 from both sides. So minus 1.5 W is greater than negative 30. When I divide by negative 1.5 with an inequality, I also have to flip the inequality. So my W is less than 20. So combining these two restrictions, I rewrite this as an inequality of 0 is less than W is less than 20. So my width is greater than 0 and less than 20. Okay, so next, I want to find a viewing window to see my function and trace the equation. I want to find, so I need to figure out a viewing window to see this. So starting out with, I start with minus 10. By default, we go from minus 10 to plus 10, both in X and Y direction. And since I'm talking about all positive numbers, I'm going to adjust my viewing window. So I know my X is going to be my width, and my Y is going to be my area. Okay. So I know the minimum the width can be is 0. And I know the maximum the width can be is 20. So I have my X minimum and the X maximum. So next, I know without drawing, if I want to multiply out to find what my leading term is, I know I'm going to multiply negative 1.5 W times W. So when I multiply negative 1.5, I'd get negative 1.5 W squared. So I know I have a degree 2 function, so it's quadratic. Since I have a negative coefficient, I know I'm going to open upside down. So my area that I'm looking for, I know I'm looking for this maximum right here. So I know I'm looking for some type of shape that looks like this. And I'm looking for the maximum here. So to find the maximum, find the width you should use to maximize the area of the enclosure. I'm going to use second trace maximum and enter, enter, enter. Okay, when I do that, the coordinates I see are x equals 10 and y equals 150. So the width I want to use is 10 meters. So I know right here width is 10. And what's the maximum area? So the maximum area is my y. So area at width equals 10 is 150 meters squared. Okay, so here is 150. Okay, so a lot of it's just knowing a maximum area is an upside down quadratic. All right, so let's try a box problem. So I'd have a piece of paper to show you this physically, what we're doing. So on this box problem, a manufacturer has a piece of tin 12 feet wide by 16 feet long. An open box is to be made by cutting a square from each corner and folding up the edges of the box, of the piece of tin. Okay, so we're going to cut out the 4 corners. And the corners are a square, so the corners are the width or length of x. Okay, so I want to write the expression of the volume of the box as a function of the corners of x. So it's asking me, I know volume is length times width times height. So now I want to rewrite my length and my width in terms of my height. So when I'm folding up my box, my height is x. So I want to rewrite length and width in terms of x. So each corner is x, right? So my length of my box actually is right here. And the whole length is 16. So I'm going to take my length is 16 minus 2 times x. And I'm going to do the same process with my width. So my width starts out as 12, but I'm cutting out 2x. So 12 minus 2x. So my volume in terms of the height x is length, which is 16 minus 2x plus width times width, 12 minus 2x times my height of x. Okay, so we have a couple questions. So it's asking me what's the domain for this situation. So again, I'm looking at this, and from a mathematical standpoint, I don't have a fraction or I don't have a radical with an even index. So I do not have any mathematical restrictions, but I do know that length, width, and height all need to be greater than 0 for a real world restriction. So I'm going to take my length, which is 16 minus 2x, and I know that has to be greater than 0. My width, which is 12 minus 2x, that has to be greater than 0. And my height, which is x, has to be greater than 0. So I'm going to solve for x. So I'm going to subtract 16 from both sides. Minus 2x is greater than negative 16. And x is less than 8. Negative 2x is greater than negative 12. So x is less than 6. And then I already have the height. So just looking at these on a number line, I have a 0, 6, and 8. Okay, so I know I need to be less than 8. So it would be an open circle and less than 8, an open circle and less than 6. And I have to be greater than 0, open circle and greater than 0. So what do I have in common is right here. So writing that as an inequality, I know I have to be between 0 and 6. Okay, same process. So volume is a little different. So this time I'm going to be multiplying negative 2x times negative 2x times x. So that would be 4x cubed. So when I'm looking at 4x cubed, I know I have a cubic. So I begin at negative infinity and I end in positive infinity because my coefficient is positive. So I know I have this shape here. So a maximum value. So I'm looking for this here. So I'm kind of using the equation to know what it is I'm supposed to be looking for. Okay, so again, I know how to set up my x minimum and maximum from 0 to 6. So I know this is going to be volume. So this is I guess I'm going to say this is my height. And here's my volume. So I know my minimum Y volume will be 0, and I just try out a couple until I find something that fits my window, and I know I can fit with 200. So I end up seeing this in my window with these settings. So I want to know what the maximum is here. So this is, what is the size square corners you should remove to create a box with the maximum volume? So again, I'm doing second trace maximum, enter, enter, enter. So this was asking me what is x equal. So when I set it up, I found x equals 2.263 and y equals like 194. So my box square should be I'm going to say 2.3. I'm rounding to tenths. 2.3 feet times 2.3 feet. Okay. And what's the maximum volume? So my maximum volume at 2.263 is about 194 feet cubed. Okay, so these are about drawing a picture, looking at the leading term, and knowing what I'm looking for. Okay.